All right, let's try this again. Guys, I recorded the whole video and I looked up and I wasn't recording, so oof. All right, so we are going to talk just a little bit about graphing speed, and then we're going to go into velocity, and that's going to be it for these video notes. All right, so we're going to talk a little bit about what we call a position versus time graph, okay? And I want you to know that when I say position, we haven't talked about that a lot, but that is the same thing as me saying distance, okay? So position versus time graph, or distance versus time graph. Okay, so that's the same thing. Let me erase that there. All right, these are the same things, okay? So let's go back and remember that we have two axes when we're graphing. We have one that's going up and down, all right? And then we have one that's going from left to right, okay? And hopefully you remember that the one on the bottom is called the x-axis. All right, and then the one that's going up and down is called the y-axis. Okay, so when we are graphing, we put the distance, okay, it's going to be plotted on the y-axis. Okay, and that means that on the x-axis, we are going to plot time. Okay, so remember, time is like seconds, minutes, hours, days, months, years. Okay, and then distance would be like meters, inches, kilometers, centimeters. Okay, now if you remember from the last video or from your notes or from the last class, and if you didn't watch the video, I hope you go back and watch it. Speed is calculated by dividing distance divided by time. Okay, so remember we were saying S is equal to D divided by t. All right, so speed is calculated by dividing distance by time. Let me write this another way just in case. S is equal to D divided by t. Those mean the same thing. Remember, a fraction is just dividing. All right, so when we're looking at a graph of it, of distance versus time, or speed or position versus time, the slope, okay, the slope of a distance versus time graph is what tells us the speed. Okay, so remember, slope is kind of like the line on the graph. Okay, or it's kind of, there's a mathematical formula for it, but the slope is the equal to the speed. So let's just make a note. Speed is equal to the slope. Okay, and we are going to have some other graphs later on, so I do need you to know that it's the slope specifically for a distance versus time graph. Okay, so let's talk about when you look at different slopes, okay, what that means. All right, so let's look. We're going to be looking at this graph down here. There's a question that's going to ask us like, hey, when you're looking at this, could you tell me, so the question down here says, if you're looking at the above graph, can you tell us when the object had a slow speed versus a fast speed versus no speed? So you probably could look at this and already guessed when, if it's at point A, point B. So you have point A, point B, and point C when it was going fast. So for example, I'm going to make this a little bit bigger. All right, so is it going fast here, or is it going fast? Let's do another color here. Or is it going fast here, or is it going fast? What's another color we haven't used? Here we go. Here. All right. So that's kind of what we're looking at. Where is it going fast? Where is it going slow? Where is it not moving? So let's go back to the notes up here and talk about that very thing. So a steep slope indicates a large position change or a large amount of distance covered in a little bit of time. Okay, so if I go from here to downtown, that's a pretty good distance. Okay, in a little time. Let's say usually it takes me about half an hour, so let's say if we got down there in 10 minutes, I had to be really booking it. Okay, so that is the equivalent of me hitting the gas and not coming off of it. All right, so with this, I'm probably am traveling at a very fast speed. Okay, a very fast speed. All right, And actually, let's go ahead and color code it. So fast speed, which would actually be that point A, fast speed, all right? All right, a shallow slope. So shallow means very, very gradual, okay? Very gradual. So steep is like if you were looking at lines, okay? Steep would be like it increases very quickly. Shallow would be it's increasing but not as much, okay? So this would be shallow. A shallow slope indicates a small position change, okay, over a long period of time, all right? So maybe I went downtown, okay, but maybe it took me 3 hours to get there. Good grief, okay? I must have been going very, very slow, okay? I must have been going very, very slow. And this is, when I say fast and slow, we're talking about average speed, okay? So over that entire period of time, all right? And then no slope, all right? So if you look at this blue line down here, this no slope, all right? That means this object is, you can write this a couple different ways. You could say is not moving. You could say is at rest. You could say it is being still, okay? Either way, however you look at it, what does that really mean? That means that the speed is 0, okay? So a 0 speed, all right? So I did these color coded for you in case you can't tell, if you hadn't picked up on that, okay? Or if you are colorblind, let's talk about what that means. So on this graph, if I look at this line that's near point A, I'm going to use a different color here. Let's do gray. Okay, so if I'm looking at this line here versus this line, okay, this is A, this is B, and this is C. I think the easiest one to pick out is point B. Point B, this line is not moving. It is completely flat. There is no slope. So that goes, if we look at the one that said no slope, we said when you have no slope, the speed is 0. So that is no slope, no speed, okay? Here, if I compare this point C and point A, or the purple line and the green line, that green line is not as sharp as that purple line. This purple line is pretty sharp, okay? Pretty sharp right here in comparison to this green one. So I would think on that purple one, I'm going much faster. So on this one, this is going to be our fast speed. And that means this one over here must be our slow speed. All right, so that is it for graphing. Let's talk about velocity just for like a couple minutes because we really kind of already covered that last week. And the calculations are going to be very similar. All right, so moving on to velocity. We said that velocity, remember you had two different things. You had scalar and vector. And if you remember, we said we were going to say velocity was vector because they both started with V. And the only difference was that velocity is speed, but we also have to add in direction. Okay, so 55 miles per hour, 55 miles per hour south, okay? So here, where I said 60 meters per second, this would be a speed, okay? Then I said 60 meters per second northwest, this would be a velocity. The only difference is I gave speed on the other one, okay? All right, when an object moves at the same speed in the same direction, the object has a constant velocity. All right, so nothing's really changing, okay? And then we talked about the car on cruise control having a constant speed, but now we could say a car on cruise control and traveling in a straight line. So maybe it's going east, or it's going west, or it's going north, or it's going south, okay? All right, and so then if we're looking at this in terms of speed, okay, we're going to say it's the same unit as speed, which is meters per second. That's typically what we use. It may change. And it basically uses the same formula except, okay, let's make a note, except instead of saying speed is equal to distance divided by time, now we're going to say velocity is equal to displacement divided by time. Okay, so this is the big difference. Displacement, distance, okay? Which just means we're going to put a direction on there. So the calculations are going to be pretty much the same. And we will do that in class tomorrow.